right, so we're asked to solve this equation here, x cubed minus 216. And we're going to see how that comes out. We'll just do the steps. First of all, you have to know the difference of cubes equation, or rather the difference of cubes factoring. So the difference of cubes, it's a pattern. So if you have a cubed minus b cubed, then it'll be a minus b times a squared minus 2, whoops, not 2, just regular ab, and it'll be plus ab plus b squared. So notice that this will work if you factor it back or multiply it back. So you get a cubed plus a squared b, then let's go over here, then plus ab squared, and then taking this negative b here, we'll go here and we'll get negative a squared b here, we'll get negative ab squared, and then finally negative b cubed. And so because these are the same but opposite signs, they cancel out to a 0. And so notice that we get back to the original a cubed minus b cubed. So that's the difference of cubes pattern. We also have a sum of cubes pattern. So a cubed plus b cubed factors to a plus b, then a squared minus ab plus b squared. Okay, so notice that when we did the difference of cubes, the first group, the first binomial, had the same sign, and then here the two end terms, the one in the front and the one in the back, are always positive, but the one in the middle will be the opposite sign of what you see here. And that works here as well. Notice here we have the same sign with the plus sign there and here, and then the two positive ends and the negative middle term. All right, so that's what we're going to need to be able to do this problem. So let's look at that again. A cubed minus 216. All right, so solve a cubed minus 216. All right, so is 216 a perfect cube? And I believe it is, but let's see. Take the cube root. A couple ways you can do this on your calculator. You might have a way of putting in a cube index for a root, or you can even do 216 to the power of 1/3. Either way. So when you do that, I'm doing it now, you'll get 6. So notice that 6 times 6 times 6, that's 6 times 6 gives you 36, and then times another 6, that gives you 216. Okay, so we just know now that 216 is a perfect cube because you can find something when you raise it to the power of 3, you get 216. So we can rewrite this as, we don't need to really change much about the first part, a cubed minus 6 cubed. Okay, so then we can use our difference of cubes pattern to do a minus 6, remember same sign, then a trinomial with the first term squared, it's the cube root of that first term there, and then the cube root of the second term squared, and in the center we're going to use the opposite sign for our center term, and it's just going to be a product of the two cube roots, so that'll be 6 times a. Now, if we're solving this and it's set equal to 0, like it was originally, what we're looking for are all the possible values of a that could make this statement true. So first of all, we can use the zero factor property, also sometimes called the zero product property, which just means that if you multiply two things and get 0, then you know that a could be 0 or b could be 0 or both. So we use that quality that we observe as being something that truly does happen. That's a property, meaning it's something we can observe. And we can use that taking each of these factors, since this is a one big thing times another big thing being multiplied, one of them has to be 0 or possibly both could be 0. So you set each one equal to 0 and solve. Now the first part, a minus 6 equals 0, is very easy to solve for. We just add 6 to both sides. Okay, and then we get a equals positive 6 as one of our possible solutions. But we also have the trinomial that's quadratic actually. And set that equal to 0. And this is something that can't be factored. So what we can do instead is use the quadratic formula. Which is x equals negative b plus or minus the square root of b squared minus 2a. Oh, I meant that to be 4ac, excuse me, 4ac all over 2a. All right, so this only works if your quadratic equation is set equal to 0 and your terms are in order with the powers going from largest down to smallest. So this term has a power on a of 2, this term has a power on a of 1, and this term has a power on a of 0 because a to the power of 0 is always 1. All right, so then a would be 1 since that's, you could consider the coefficient to be positive 1 there. Then b is going to be 6 and c is going to be 36. So although we do have an a here, we can change it temporarily to be an x just so it doesn't confuse you. Typically we see these with an x in them, and that's why this equation says x equals. All right, so now we'll go ahead and plug those values in and simplify. Okay, so now we have x equals negative b plus or minus. I like to create an empty shell where I can plug everything in. Okay, and then let's take our values. We have a is 1, and that goes here and here. Then you have b is 6, so that'll go here and here. And c is 36. Okay, so now we need to do the math to simplify that, and then we will have our 2 more values to put in our solution set of all the things that could make the original equation true. So x, just keep on simplifying. We have negative 6 plus or minus, and notice that the plus and minus is going to give us 2 separate answers from this one formula after we get to a certain step in the simplifying process that will happen. 4 times 36 there, and 2 in the bottom. And what is 4 times 36? 4 times 30 is 120, 4 times 6 is 24, so you can do it in your calculator as well. You should get 144, which is negative 144. All right, and then 36 minus 144, negative 108. Uh-oh, we have a negative under our radical symbol, and it's an even root. And we know that you can't raise something to an even power and get a negative result. So this doesn't exist in the real number system. So we call it imaginary, and we use the imaginary unit. So I can write it like that, but I can also write it like this and put the I on the outside, because I is the imaginary unit that is equal to the square root of -1. Oops, touched the wrong thing. Oh, what's going on there? There we go. All right, so now we have all of this over 2. Now, are there any perfect square roots that divide into 108? I think there's 2 that I noticed. 4 times 9 is 36. Oh, 108 divided by 36. Yeah, yeah, yeah. So I just tried dividing 108 by some perfect squares, and I found the largest one that goes in is 36. So I have 36 goes in evenly 3 times. Okay, and that's helpful to us because then we can take the square root of 36 and let it escape from out from under the radical. Plus or minus, so the square root of 36 is 6. I still have my square root of 3, and then the I outside of that. And finally, the 2 goes evenly into both of the terms in the top. So that can be reduced as well. And so then we end up with -3 plus or minus 3 roots of 3. Lots of 3's going on here. All right, and so we can separate that into 2 separate answers. So combining that with the 6 that we got earlier and these 2 answers, finally we come up with our solution set. So this was a bit of a bear of a problem. All very doable, you just have to have patience. So we got 6 as one answer, that's a real solution. Then we got 2 imaginary or complex imaginary solutions. It's -3 plus 3 square root of 3 I. Okay, so that was the one with the plus. And then -3 minus 3 square roots of 3I. Oh my word. So there you have it. I hope that helped. Please let me know.